cable is the runway. The sling is attached to a trolley which rides on the cable. The plane is fitted with a hook. It catches the sling, rides down the cable on the trolley, and is braked to a stop. Taking off, the plane is hooked to a distant trolley. The motor is revved. The pilot begins his run, gains flight speed, unhooks the plane from the trolley, and takes off. Four masts hold up the runway cable. The runway is suspended at each end by a V-shaped bridle cable. The bridle cables are really prolongations of the runway cable. Each bridle cable runs over a masthead sheave and is anchored to dead men sunk into the ground. Mast, runway cable, bridle cable, masthead sheaves, dead men, pair for each bridle cable. Each of the four bridle cables is anchored into the ground by an anchor assembly. The assembly consists of half dozen different parts: anchor plates, anchor rods, bearing plates, anchor bridle, equalizer sheave, turnbuckles. The anchor rod meets the anchor plate underground and is firmly secured. The anchor rod is connected to the anchor bridle at the bearing plate. The anchor bridle runs over the equalizer sheave. The strain on the bridle cable is adjusted by the turnbuckles. As the anchor assembly actually looks when it is set up. The bridle cables run over the mast, do not support them. Four sets of stays hold each mast upright. The stays are secured by anchor rods locked in anchor plates below ground, just like the dead men shown before. Note turnbuckles. The mast itself is made up of sections of plywood tubing. The sections are coupled together with split steel sleeves. The mast stands on a pivot at the base plate. At each end of the runway cable is a triangular bridle plate. It's at this plate that the runway cable is fastened to the two bridle cables. The sockets of the three cables fit snugly into the bridle plate. The triangular bridle plate also holds the two lifting devices, the davit for the man lift, the derrick for the plane lift. The davit fits into a sleeve pipe which is welded into the center of the bridle plate. The man's center lock can easily swing around and reach any part of the apparatus he has to work on. The derrick is bolted onto the triangular bridle plate and to the ends of the bridle cables. Block and tackle are attached to the derrick and the plane is hoisted up or lowered. The man lift is worked by tackle. The lifting line runs over sheaves on the davit and one at the triangular plate, then through triple-eyed fair leads, which are clamped along the bridle cable, back to a block at the masthead, down to and through a block at the base plate, and out to a snubbing post. The plane lift is also operated by tackle, which runs over another sheave located at the triangular plate, through another eye of the triple-eyed fair lead, back to the block at the masthead, and down to a separate single block at the base plate. out the 6 purchase blocks and attached to a snubbing post. Note the lifting line. The fair leads, the double block, down the mast of the single block. The landing trolley hangs vertically from a single wheel which runs freely on the runway cable. The landing trolley is shackled to the sling. The sling has 3 loops. The frame holds the sling out to its full width, 6 feet. The frame hangs down from the derrick arm. Each of the frame's arms is jointed, is 9 feet long. Tabs on the outer loops of the sling are clipped to the arms of the frame. When the plane hooks the sling, the loops are pulled out of the tabs. The frame stays put on the derrick arm. The sling itself, shackled to the trolley, is free to run down the cable runway as the slow-motion shot shows. What actually stops the plane is an arresting device called the brake drum. Note the brake line at the bottom of the landing trolley. The brake line leads to the drum. The brake drum works on the principle of a giant fishing reel. The plane hooks on, rides the trolley. The arresting brake line resists the momentum of the plane. The brake is applied gradually. The takeoff trolley rolls very smoothly on 2 wheels. Holding the plane to the takeoff trolley is the takeoff sling. Unlike the 3-loop landing sling, the takeoff sling is a single 4-foot nylon rope. In hoisting the plane up, the bottom stirrup of the takeoff sling is locked into the plane hook. The derrick block is hooked into the center ring of the sling. When the plane is pulled up, the free-swinging shackle at the top end of the takeoff sling is hooked into the trolley. The derrick block is then slipped out of the center ring, and the plane has been transferred from the derrick to the trolley. When the plane has made its run, contact with the takeoff sling is broken by pulling the lanyard in the cockpit. A travel release mechanism serves the same purpose as chocks do on a ground runway. It keeps the plane from starting on its run before the motor is sufficiently revved up. The travel release is a heavy spring. 1 line holds the plane back. The second line trips the spring. Trip the release and the whole device falls to the ground. When the plane takes off, the takeoff trolley slows down and slides to the end of the runway cable. A spring coiled around the cable stops the trolley, acting as a shock absorber. At the end of the spring is a cone. The cone is not attached to the spring. It is controlled by a slider rope which reaches the ground through the third eye of the triple-eyed fair leads on the bridle cable. This device is used so that the man on the ground can slide the trolley back along the cable for the next takeoff. To go over the takeoff procedure once again, the plane is hooked onto the derrick block and hoisted up to the takeoff trolley. A man is sent aloft to unhook the center ring off the derrick block and attach the top shackle of the takeoff sling onto the trolley. The travel release holds the plane back while the pilot revs the motor. At a signal from him, the travel release is tripped. The pilot makes his run, gains flight speed, takes off. All the equipment the plane needs is a hook which is bolted onto the fuselage. The takeoff release on the back of the hook has been shown, the finger and the trip. As for the landing, the arm is fastened onto a swivel joint. Running under the length of the arm is a bungee shock absorber, permitting the arm to bend down. The hook itself is fitted into the telescoping tube of the arm. The swivel, the bungee shock absorber, the telescoping mechanism, all three, take up the shock of the impact when the plane hits the landing sling. As the plane hooks on, the catching assembly on the plane swivels back almost to a horizontal position. The bungee shock absorber, as well as the telescoping mechanism, cushion the impact of the landing. Again, in slow motion. A 9-man crew sets out to put up the rigging, this time choosing rough, uncleared terrain, operating as if under field conditions. A 5-ton truck brings in the crew and all the necessary equipment. If no roads existed, the equipment and men could be flown in by cargo planes and dropped by parachute. The equipment is sorted and then carried to those points on the field where it will be needed. The site has been surveyed and measured in advance. The runway cable is 500 feet long. The distance between the triangular bridle plate and each mast is 128 feet. The masts are 160 feet apart. The distance from each mast to the anchor assembly is 212 feet. At each end of the runway, on the triangular plate, there is a davit and derrick. One mast at either end will hold the double block for the man and plane lift lines. Along the bridle cable, reaching from the bridle plate to this mast, the triple-eyed fairleads will be clamped. The slider rope for the coil spring cone will run through the third eye of these fairleads. The brake drum will be fastened to the second mast at each end. The nylon brake line will run through a single-eyed fairlead clamped on the bridle cable, reaching from the bridle plate to this second mast. The runway cable is unreeled along the path it will follow between the two bridle plates. The bridle cables are unreeled. They meet the runway cable on the ground at the point where they will be fastened onto the bridle plate. The process, of course, is duplicated at the other end of the runway cable. With the cables laid out on the ground, work begins on the mast. Holes are dug for the anchor plates to which the mast stays will be anchored. Anchor plates are sunk into the holes. Anchor rods have been driven in. Firmly grip the anchor plate. The mast is inserted into the base plate and secured on a pivot with pins and cotter keys. The mast is built up to its 63-foot length by coupling sections together with split steel sleeves. Note round sections of tubing, an improvement on the hexagonal sections in the mast previously shown. The top of the mast is fitted out before it is raised. The bridle cable is rolled through the masthead sheave. At this time, too, the double block is attached to the top, since this mast is the one used for the man and plane lift. Note I for the double block. The triple-eyed fair leads are loosely clamped on the bridle cable. The lines for the man and plane lift are run through. The slider rope for the coil spring cone will run through the third eye of the fair leads. Stays are attached to the mast, and once that's done, the mast is ready to be hoisted up. A raising boom is used to pull the mast upright. The front stays of the mast are hooked onto the top of the boom. Mast and boom turn on the pivot. With the mast a few feet off the ground, all dangling stays are shackled to their dead men. Guy lines are used to keep the mast steady. The mast is up, the boom down. Now the front stays are taken off the boom and shackled to the dead men. The boom is unfastened, removed. Turnbuckles are adjusted to equalize the pull of the stays. In the background, note a second mast already raised. The bridle plate has to be put together now. You may not recognize it on the ground. This is how it looks assembled in the air. The plate is built up. Runway cable and the two bridle. The arms of the derrick are bolted along the bridle cables. The derrick assembled. Already welded into the center of the bridle plate is a sleeve pipe into which the davit is inserted. The man lift cable runs through sheaves. At this time, too, before the runway is raised, all other equipment should be assembled. Trolleys, coil spring, slider cone, and the pulley on the bridle plate for the slider rope. Bridle plates are fully assembled at both ends of the runway so that the plane can take off and land in either direction. Before the runway can be raised, the anchor assemblies for the bridle cables have to be hooked up. The two dead men for each anchor assembly have been sunk. Bearing plates are fitted in. Note end of anchor rod. The bridle cable runs through the equalizer sheave for the second deadman. The entire unit is now assembled and lies on the ground. The bridle cables run loosely over the tops of the masts. At one end of the field, the two bridle cables are shackled onto their anchor assemblies before the runway is hoisted up. Therefore, at the other end of the field, the bridle cables will not reach their anchor assemblies until the runway has been raised. Block and tackle are fastened on the bridle cables, beginning the job of raising the runway. Teams work at each side, pulling together on the two bridle cables so that each of them shares the load. When the runway is a few feet off the ground, the lift lines running through the fair leads are checked. The turnbuckle is shackled onto the bridle cable. Tension is adjusted by the turnbuckles. Step for step, the process has been duplicated with the second bridle cable. Both bridle cables are now anchored. The runway is up.